Hi guys, so here we have been given a code and we have to predict output of this code. Okay, let's try to find and analyze the code, what it does. So we have an integer variable a initially assigned to 0, and then we have a character pointer x, and then we are assigning address of a to x, and then we are assigning value of 512 to variable a. So just to understand more properly, let's have the binary representation of value a. So initially value a has 0, so this is the binary representation. Let's assume integer takes 2 bytes. So similarly the 512 will become like this. Now on line number 8 and 9, using the pointer, he is trying to modify 0th byte and first byte. So in general, the rightmost byte is called LSB, least significant byte, and the leftmost byte is called MSB, most significant byte. Okay, so like this. Now using the pointer, we are trying to modify the 0th byte. So in general, 0th byte is least significant byte, but it depends upon the compiler. So few compilers treat LSB as the 0th byte. Few compilers will treat MSB, most significant byte, as a 0th byte. So that depends upon the notation called little endian and big endian. So let's try to understand what is this little endian and big endian with an example figure here. Say for example you have a 4 byte data, and as I said, like the rightmost byte will be least significant byte and the leftmost byte will be the most significant byte. In memory, in the little endian format, how the data is stored is the LSB will always go to the lowest address. As I said, like this is a 4 byte data, so the addresses will be let's assume the starting address will be 100. So lowest address will be 100, and then 101, and then 102, and then 103. So highest address will be 103. So in the little endian format, remember the LSB will always go and sit at the lowest addressable byte, that is at 100, and MSB will go and sit at the highest addressable byte. So in this order, 0, 1, 2, 3. Whereas in the big endian format, the MSB will go and sit at the lowest addressable byte. In the MSB, the most significant bit or byte will come and sit at the least address, that is 100. So at 101, byte 2 will come and sit, and 102, byte 1 will come and sit, and 103, the byte 0 will come and sit. So this is how the data represented in the memory using little endian and big endian. I am repeating one more time. In the little endian, the least significant byte will come and sit at the lowest address. In the big endian, the MSB, most significant byte, will come and sit at the lowest address. Just to make things more clear, let's take in data as an example and see how the data is represented in the memory. For example, again you have a 4 byte data. So 12 will 1 2 will be 1 byte, 3 4 will be another byte, 5 6 will be one more byte, and 7 8 will be the one more byte. So here the 7 8 represents the LSB and 1 2 represents the MSB. So as I said, like in the little endian, the LSB will come and sit at the lowest address. See, 78 came and stored in the 100th address, whereas 12, which is MSB, came and sit at the highest address. Whereas same data in big endian format, I said like MSB will come and sit at the lowest address. So the 12 came and sit here, and the 78 LSB will go and sit at the highest address. So that is 78 at 103. I hope the things are clear with the big endian and little endian. Let's go back to our code and see the same way how the data, this 1 and 2, will be modifying if we follow little endian, and then same will be how if we follow big endian, right? So in little endian, as I said, like the first byte or the least significant byte will come and sit at the least address, lowest address. So here the 0, which is the like 1, is come and sit at the this address, least significant byte, or in the memory this is the lowest addressable byte, right? So one come and sit at the this place, this byte place. So let me copy paste the same thing. So the 1 will come and sit here, and the 2 will come and sit here. Anyway, this is already 2, so this is how. So this value is nothing but 513. Okay. Similarly, same number in the big endian format. Let's see. So the 1 will come and sit at the highest addressable byte. So that is because this is a 2 byte data. So this will be modified and storing the value 1, and the next value will be come and sit at the lowest addressable byte. So this will become 2. I'm sorry, 2. So this value is nothing but 258. So in the little endian format, the value will be 513, and in the big endian format, the value will be 258. So if you see the options, we have both B and C. But again, I'm repeating, these little endian and big endian format way of representing the data or storing the data in the memory, it's not in our control. It's purely based out of compiler decision. So how the compiler stores its data declared or assigned in the program in the memory, it's purely up to the compiler. So that's why we can't decide is it a 513 or a 258. So the answer will be the A, machine dependent. Okay, let's try to run this code and see what output comes. So we got 513. So this particular compiler is following little endian format. So that way we can't directly come and choose option B. As I said, like some other compiler from GCC family may choose big endian format, or so we don't know, and we can't decide. So the best answer is machine dependent. So A is the most probable answer for this question, and not D. We don't get any compiler errors. So as you see here, we don't get any compilation errors. So the answer is machine dependent. Thank you.